What if humanity could unlock the secrets of creation itself, not in theory, but in practice? Imagine a lab experiment so ambitious it could recreate the moment our universe burst into existence. This isn't the plot of a science fiction blockbuster, it's a tantalizing idea at the cutting edge of cosmology and theoretical physics. The concept of simulating inflation and even creating mini-universes in a laboratory raises questions that blend science, philosophy, and the boundaries of what's possible. Could we replicate the Big Bang in controlled conditions? What would it teach us about our origins, and what ethical dilemmas would it pose? Let's embark on a journey to the frontier of human understanding, where the cosmos might one day be born in a lab. The origins of inflation, setting the stage for creation. To grasp the idea of simulating inflation, we must first understand the phenomenon itself. Cosmic inflation was a brief but extraordinary period of rapid expansion that occurred approximately seconds after the Big Bang. During this time, the universe expanded exponentially, faster than the speed of light. This inflationary phase smoothed out irregularities, set the stage for galaxy formation, and determined the large-scale structure of the cosmos. Yet, the precise mechanisms behind inflation remain elusive. Scientists hypothesize that a quantum field, the inflaton field, drove this expansion, but the field's origin and properties are still mysterious. Key mystery: could this inflaton field, the engine of inflation, be recreated or simulated in the lab? If so, what insights might it unlock about the universe's earliest moments? The physics of simulating inflation. Simulating inflation isn't just a matter of flipping a switch. It requires recreating conditions that are almost inconceivably extreme. Densities trillions of times higher than those in the core of a neutron star and temperatures hotter than the interior of the Sun. Here's how scientists are tackling the challenge. 1. Quantum fields and vacuum states. Inflation likely began when the universe was in a false vacuum state, a high-energy configuration that rapidly decayed into a lower-energy state, releasing vast amounts of energy. This energy drove the expansion of space-time. To simulate this, scientists need to manipulate quantum fields, the building blocks of reality, to recreate a false vacuum in a controlled environment. Experiments might involve cooling systems to near absolute zero, creating conditions where quantum fields behave in ways similar to those theorized during inflation. 2. High-energy physics. Particle accelerators like the Large Hadron Collider, LHC, allow us to study conditions similar to those just after the Big Bang. By smashing particles together at nearly the speed of light, we can explore the energy regimes where inflationary physics might emerge. Future accelerators, such as the proposed Future Circular Collider, could push this research further, potentially allowing scientists to probe energy scales close to those of inflation itself. 3. Quantum simulations. Beyond physical experiments, quantum computers and advanced simulations are paving the way for understanding inflation. These tools allow physicists to model the interactions of quantum fields and space-time dynamics at scales that are otherwise impossible to observe directly. While physical recreation of inflation might be decades away, computational simulations could yield insights far sooner, testing theories and guiding future experiments. The dream of creating mini-universes. Taking the concept a step further, could we go beyond simulations and actually create a new universe? Theoretical framework. Some inflationary models predict that our universe might not be unique. Instead, inflation could produce countless bubble universes, each with its own physical properties. Theoretically, it might be possible to create a bubble of space-time in the lab, triggering a localized inflationary expansion. How it could work: a high-energy quantum field could be manipulated to create a tiny patch of space-time, isolated from our own. If this patch underwent inflation, it could expand into a new universe, possibly with its own set of physical laws. Containment: the mini-universe would need to be self-contained, expanding within its own space-time bubble without interfering with our universe. Current challenges. Energy requirements. The energy needed to recreate inflationary conditions is astronomical, far beyond what current technology can provide. Stability issues. Even if we could create a mini-universe, ensuring its stability and isolation would be a massive technical hurdle. Ethical concerns. If a lab-created universe could support life, what responsibilities would its creators have toward it? What could we learn from simulating inflation? Even partial simulations or small-scale experiments could revolutionize our understanding of the cosmos. Validating inflationary theories. Simulations could help physicists test competing models of inflation, shedding light on questions like: what caused inflation to start and stop? How did quantum fluctuations during inflation seed the structure of galaxies? Insights into dark energy. Inflation and dark energy share key similarities. They both involve the expansion of space-time driven by mysterious energy fields. Studying one could reveal insights into the other, potentially solving one of the greatest mysteries of modern physics. Exploring new physics. Simulating inflation might uncover phenomena beyond the standard model of particle physics, such as quantum gravity effects or higher dimensional interactions predicted by string theory. Ethical and philosophical questions. Simulating or creating universes isn't just a scientific challenge, it's a profound ethical and philosophical one. Are we playing God? Creating a universe, even in a controlled environment, raises existential questions about humanity's role in nature. Should we attempt such experiments? What if life emerges? If a lab-created universe developed conditions for life, would we be responsible for its well-being? How would we even know if life existed within it? The simulation hypothesis, the idea of creating universes in the lab, also invites speculation. Could our own universe be the result of a similar experiment conducted by an advanced civilization? Exploring this possibility brings us closer to answering questions about our own origins. The future of simulating creation. While the dream of creating universes may still be far off, every step forward in understanding and simulating inflation brings us closer. Advances in quantum computing and high-energy physics could enable more accurate models of inflation. Collaborative projects, like next-generation particle accelerators, could push the boundaries of energy achievable in laboratory settings. Could the ultimate experiment, the creation of a universe, help humanity answer its oldest questions? The quest for understanding the origins of everything continues to inspire, challenge, and push the limits of what's possible. Why it matters. Simulating inflation isn't just a scientific challenge, it's a window into the most profound questions about existence. Why does our universe exist? What are the fundamental laws of nature? Could we ever truly understand the origins of everything? Through these experiments, humanity edges closer to deciphering the mysteries of the cosmos. And perhaps, one day, we may hold the power to create universes, not just to observe, but to understand the very essence of creation itself. In the quest to simulate the cosmos, we may not just uncover the universe's origins, we may rewrite its destiny.